Okay, we continue with our contingency coefficient, which is another measure that we can use that incorporates the calculation of chi-square. And all of these measures exist to give you some additional information about chi-square, to bolster chi-square, since we know that chi-square is um, sensitive to large sample sizes. We know that when you have small sample sizes, there are problems if you have those empty cells or there's very low frequency cells in it. So these all provide sort of a bolstering to our chi-square calculations. So the contingency coefficient is generally used on larger cross tabulations. So when you have at least a 5 by 5 table where you have 5 columns and 5 rows at least, and it can only be used when you have equal rows and columns. So they have to be in the shape of a square. So a 5 by 5, a 6 by 6, and so on. The example that I'm going to show you uses the 2 by 2, but I just wanted to show you how it's calculated and where the numbers get plugged in, and I didn't want to come up with another example since we're already using this religious attendance example. So if you look at the formula, you have the calculation for chi-square, that value in the formula twice, and you have the sample size. And again, so it's fulfilling all of those requirements. It's taking the square root to deal with the fact that chi-square gives you a square result, and it's taking into account the sample size. So here is the calculation for assessing religious attendance. If you remember in the phi example, our calculation of chi-square was 34.2. So we plug that number into our formula here, and it goes in here in both places. And we run through our calculation for the contingency coefficient, we get a value of 0.38. There isn't really a direct interpretation of the contingency coefficient, but the farther you are from 0 and the closer you are to 1, then the more related those variables are. Again, these are not standalone statistics. We might present phi without chi-square, but we would not present the contingency coefficient and some of these others without also incorporating chi-square into our reporting if we were reporting statistics. Again, you can't generally use it unless you have a large, at least a 5 by 5 table. That's not what I did in this example, but that's generally when it is most reliable and when the results are the most helpful. There is some more information at the statistics how-to page on the contingency coefficient and when it's used, and it runs through an example. I'm also going to talk in this video about Cramer's V. And what Cramer's V offers is, phi was just for a 2 by 2 table. So you couldn't use it if you had more than 2 columns and more than 2 rows. And we just talked about the contingency coefficient, which can only be used when you have, or is best used if you have large crosstabs and you have an equal number of rows and columns. Cramer's V allows us to do crosstabs when we have rectangles, which means that we have either more columns than rows or more rows than columns. So when you have an asymmetrical independent and dependent variable in terms of the number of categories, Cramer's V is that additional statistic that we would run to bolster chi-square. So the calculation, again, we have that chi-square value in there, and we have in for our number of cases, we have a new symbol here, and that is K. And K stands for the number of rows in the table or the number of columns in the table, so whichever one is smaller. So if we have a 3 by 2 table where we have 3 columns and 2 rows, then our K would be 2 because it is the smaller of those numbers. And that's what we're going to see in the example here that I have. And I didn't use the sex because we only had 2 categories, male and female, in that data. In this data, we have, I've used race instead and just sort of formulated some numbers. So we have white, black, and other for religious attendance. We have attend weekly or does not attend weekly. So you can see that we have a rectangular shaped crosstab because we have more columns than we do rows. We have 3 columns, white, black, and other, and we have 2 rows, attend weekly and does not attend weekly. So we have that rectangular shape. So we know that Cramer's V is the one we want to use. In the calculation of chi-square, which I did using that chi-square calculator the link is in the discussion of phi that you can use. we have a chi-square of 14.14, and that was statistically significant at the 0.01 level. So in the calculation of Cramer's V, so we have our chi-square value here, we have our n here, that's our sample size or our total number of cases, and we have 2 here for our value for k. That's because there were 2 uh, rows attend weekly and does not attend weekly, and that's the smaller of those 2 numbers. So we had 2 rows and 3 columns, so we're going to use 2. Plug all of this in and start our calculation, and we end up with a Cramer's V value of 0.28. The interpretation of Cramer's V, when you have a value that is above 0.25, it is considered to be very strong. There's a link here about the interpretation of it and what we do, so I'm going to go ahead and open that and kind of show you where that is. So anything that is 0.25 or higher is considered a very strong relationship. And you can see how those other pieces would stack up. If you calculated Cramer's V and you got a 0.13, you would be in this section right here, 0.13 moderate relationship. So that's how you would report it.